Hello, lovely human. Jen Foxpot here for another edition of STEM Bites, where we tackle your seemingly simple questions about science, tech, engineering, and math. Oh, yeah. Today, we have a fabulous question from our lovely friend, Mama Llama. Woo! Yay, Mama Llama. Okay, Mama Llama, what is your question today? Well, I would like to know what is a complex number, or really, what is an imaginary number? Is it really imaginary? Great question, Mama Llama. And I also would like to point out that Mama Llama is very interested in mathematics, alliteration. Hey, there we go. Moms had to do a lot of math, so it makes sense. Okay, so to tackle Mama Llama's question, what is a complex number? Or really, what is an imaginary number? Is it actually imaginary? Did we just make it up? Well, yes, we totally made it up, just like we made up all of numbers and like how we made up all of language. So, however, imaginary numbers are real physical things that do exist in the real world, right? Okay, so I just said we made up numbers. We assigned labels to them and we assigned quantities to them. There's a really cool book that I read when I was a kid that talked about why we count to 10. It's really because we have 10 fingers. If we lived on a planet where we had 2 fingers, we would count in binary 1, 2, or maybe 0, 1. If we were an alien species that had 8 fingers, we'd probably have base 8 numbering system. So we would count 1, 2, 3, 4, 5, 6, 7, 8, and then we would start over. So pretty cool. It's all arbitrary, right? These are choices that we have made. And for better or worse, we're kind of stuck with a lot of those choices. However, at certain points, we hit a, a barricade and we hit a problem where our current system of numbers doesn't help us solve the problem. And so mathematicians or scientists, they'll be like, "Excuse me, I would like to add something to our number system." And that is exactly what happened with imaginary numbers. So, if you recall from uh, math in school, you cannot take the square root of a negative number. So, like if I were to say, what is the square root of -4? Your elementary or middle school math teacher would be like, no, you can't do that. That is cheating. Um, because if you square -4, whoops, if you square, wow, okay, if you square, let's stick with consistency here. If you square -2, that equals 4. And if you square 2, that also equals 4. So there's no way for me to square a number in our current number system to be able to get -4. And so a lot of people think that this is just not possible. However, because we get to define things in this world, we can define a new number that equals the square root of -4. So cool. So, what we can say instead is we're gonna use another color because we're making a number. Okay, so we can define I like my little script eyes, to be equal to the square root of -1. Pretty, pretty cool. And then that way, if we say, what is, oh, let's get my green again, then we can ask, what is the square root of -4? Well, then we can say that it is 2i, because we can pull out the square root of 4 times the square root of -1, and then we can solve those separately to get 2, and then we just said that this is the definition of I, and so we get 2 times I, where I is our imaginary number. Okay, but you might be thinking, we just pulled this out of thin air, right? We just stated that we are going to represent the square root of -1 as this letter for the end of all time. And yeah, pretty much. But also, that's not really any different than any other number that we have defined. 0 didn't exist for a very long time until folks, I want to say the Middle Eastern folks invented it. Double check me on that. I'm not super great at history, but it is fascinating and important. But yes, the concept of 0 was also invented, just like we had, because there are things that we need to represent with 0, just like there are things that we need to represent with the square root of -1. So a complex number is a number that combines real numbers with imaginary numbers. A complex number, ooh, more colors! I love using colors, it makes me so happy. So a complex number C is going to equal some real number A plus another real number B times I, the square root of -1. So this is called the real part. Oh, that's some really bad handwriting. And this is called the complex part. I have to say, I don't really like the term imaginary because it makes us think that these numbers don't exist in reality. They totally do. If you have taken a physics class, you'll be like, yep, can't get away from I. Shows up everywhere. And physics is the application of mathematics to describe reality. A simpler example that I can kind of make really quickly is a flexible hanging chain. So let's say I have a fence where I have a chain. I don't know, I'm really going to be really bad at drawing this. Some of y'all are like, you draw circles really well. Well, now you can put me in my place by being like, that doesn't look like a chain. Shh, it's fine. Use your imagination. Okay. We're talking about imaginary numbers. Let's use our imagination. Okay, so a flexible hanging chain suspended between 2 points A and B actually has an equation that requires imaginary numbers. So the equation that maps out the way that this chain hangs, the shape of this chain, relies on imaginary numbers. If you're curious, I looked this up. It's y equals a, the hyperbolic cosine x over a. I believe, don't quote me on what a equals, but it's some function of the material type and the distance between the points and all that good stuff. Length of the chain, that kind of shenanigans, probably density of the chain, material properties, good times. Anyway, the whole point is that imaginary numbers show up in real life. They're not imaginary as in fictional. They're imaginary as in we had to define them so that we could describe things in real life. Because it turns out the universe doesn't care about our rules. And that's kind of the difference between math and physics. I personally didn't really like math until I found physics, and I was like, oh, you can use math to make predictions. That's so cool. My pure math friends are like, excuse me, math is beautiful in its own right. And to them, I say, yes, accurate. I'm glad that you're doing what you're doing. Personally, I prefer physics, but I'm glad that there are people that prefer the pure math because that stuff is really important. A lot of times, physicists are able to solve really hard problems because the mathematicians have paved forward. And also, things that excite you and bring you joy don't have to always have practical applications. The pure pursuit of knowledge is valuable in itself. So, imaginary numbers exist in reality. Okay? They're not only in our imaginations, they show up in the real world. And they're very important. The naming is tricky. That's why I like to use the phrase complex number. I think that the concept of imaginary numbers can be really, really confusing. But hopefully that clears it up and makes it less confusing for you. I hope that Mama Llama is satisfied with our answer. Please let me know if you have any questions about complex numbers, imaginary numbers, numbers in general. Math is so cool. It is just a language, and learning how to read it is really, really powerful. So bug me with your math questions or any other science, technology, engineering related questions. Thank you very much for hanging out with me while we learned about complex numbers, and I will see you next time. Bye!